Today we are finishing up our lesson on quiet eruptions and shield volcanoes, and we just have a little bit left to do. Remember, we said with these quiet eruptions and shield volcanoes, they were formed on hotspots, and those hotspots don't move, but the plates do move, and the plate is going to drag that volcano off the hotspot. Well, what happens once the volcano is dragged off the hotspot? So that's what we're talking about today. And there are three things that we're going to talk about. We're going to talk about seamounts, guyots, and atolls. So let's just get into it. Seamounts, that's just kind of the general one. So we're going to start with a picture. So go ahead, turn to the back, label your picture seamount or seamount. Let me change color here. So what I'm going to do is I'm going to draw the ocean floor. And when I draw the ocean floor, kind of look at this picture, I'm going to draw it sloping up slightly. Okay, not really very much. It's going to be mostly flat, but maybe sloping up just a little bit, like that. Okay, that's the ocean floor. Let me put the water on. So here is the ocean. Okay, so that blue is the ocean, surface of the ocean. Let me get some red, and the red is going to be our mantle plume and hotspot. So the mantle plume and hotspot here. So I have our mantle plume MP and our hotspot HS. So you notice that the mantle plume is causing the ocean floor to slope up a little bit right where the mantle plume is coming up. So mantle plume is right there, hotspot is right there. What's that going to do? It is going to make a volcano. So it's going to make a shield volcano on top of it. Let me change black to black. So I'm going to put a gently sloping volcano on top of it. Very simple, very easy, nothing special. Okay, there's my shield volcano. And I put it quite a bit out of water. For example, it's how the big island of Hawaii is now. If you want to also put a magma chamber in there, you can go ahead and put a good sized magma chamber. So this would be now. Well, what's going to happen in a million years or so? This plate is going to move. So the plate is going to go that way. So in, let's say again, a million years, so I'll say 1 million years in the future, now the hot spot is still going to be over here, but this volcano is now going to be here, and I'm going to put it just barely dipping above water. So the island has gotten a lot smaller. Okay, well, let's go forward in time again. So now let's go to maybe 2 million years, let's say. Again, the hot spot is still going to be over here because they don't move, but now my island is going to be completely submerged. Okay, that is when it is called a seamount. Okay, so that is the seamount. So if you want to get your definition, you just say a seamount is a submerged volcano because the plate dragged it off the hotspot. And this picture is basically showing that. Here's the Hawaiian chain. Again, you see that same thing. The biggest one right over the hotspot and getting smaller as they go farther from the hotspot. So that's the first type. If you understand seamounts, next two should be easy. They're just special types. So the next special type of seamount is a guyot. And if you want to draw a picture for a guyot, you can. If you feel that you're going to get it once I draw my picture and you don't think you need to draw a picture, then that's completely up to you. So basically what I'm doing is I'm drawing the same picture that I just drew. Okay, so same picture I just drew. There's the ocean floor. Here's the surface of the water. We have our hotspot, mantle plume under here. And then I'm going to make my volcano. So now, if I can get my color back. Okay, So I draw my volcano, just like we had before. Okay, so same picture we had last time so far, just my island there. Now, again, this is our now. This is now. Okay, we go again like a million years in the future. We know that this volcano is going to start to submerge. But what if this volcano is made of fairly soft rock, or the ocean is very violent in the place where that is? As it submerges, it can erode the top of that volcano off to be flat. So by the time it's completely submerged, let's say in 2 million years, again, I'm just making up these numbers. So now our seamount has a flat top. That's all a Guyot is. Okay, so if you want your definition, a Guyot is a seamount with a flat top because the volcano was eroded as it submerged. So just like the seamount, but now the top gets eroded off flat. And here you can see them. Okay, so that's a Guyot. The last type is called an atoll. And this one you probably should draw just because it's slightly more complicated. Again, it's the same general idea, but like I said, a little more complicated. So I'm going to start with drawing the same picture that we drew for the seamount. So I'm going to draw and leave yourself a little bit of room below this one. So draw your picture, label it atoll, leave a little bit of room before your underneath your picture because we're going to draw something beneath it. So I'm drawing my ocean floor, again, just like I did with my seamount, gradually sloping upwards, up. All right, something like that. And then I put on my hotspot and mantle plume, put it right there. I need to put on my ocean level. So here's the surface of the ocean, like that. And then I need to draw my volcano. Okay, so here's my volcano. Again, this is the now. So there's my volcano. Just the same picture that we drew maybe twice now already. The difference now is, though, this volcano is going to be in tropical ocean water. So growing around this volcano is going to be a little coral reef. So what I'm doing is I'm drawing a ring of coral that's going around this volcano. Okay, so there's my ring of coral that's going around this volcano. Again, in the future, this volcano is going to be dragged off the hotspot by the plate. So again, if I do the same thing, let's go 1 million year in the future. Now my volcano, I'm going to put it just barely above water like that. But the thing is, my coral around it has to grow taller. So the coral was on this part of the volcano, so that part of the volcano is now down here. It's further underneath the ocean. So the coral has to grow taller to get to the sunlight so it can survive. So I have my coral being taller, and you'll notice that I have a bigger amount of water here. So smaller island, more water, and then my coral ring. Hopefully you can figure out what the next one is going to look like. So I'm going to go again another million years into the future or so. 2 million years ago, or 2 million years in the future. Now my volcano, again, is completely underwater, but that coral, which was kept growing to the surface, is now going to be extended up here, like this. So what I'm left with is only my circle of coral. Okay, and that's going to be the atoll. So that's kind of my side view. But now let's draw a top view. So let's draw a top view. So if you were flying in an airplane over one of these atolls, what would you see? Well, let's look at this first picture here. So what would you see in this picture if you flew over it? Well, you see a ring of coral with an island just right inside. Let me see how well I can do this. So there's my volcano, oops, with my ring of coral around it. Then over time, my island now, look at that, my island is smaller, but my ring of coral is going to be the same size. So draw your ring of coral to be the same size as it was, but the island is smaller. And then we go kind of to our last picture, and now we're not going to have an island at all. We're just going to have our ring of coral. Okay, and that's our atoll. So if you want to get your definition before I show you some pictures, the atoll is a ring-shaped island made of coral formed as the volcano submerges. Okay, so the ring-shaped island made of coral formed as the volcano submerges. Now if we look at some pictures, here are some pictures of these atolls. You see these ring-shaped islands made of coral. Okay? I'm going to show you more pictures in class too. Some really neat ones. This is Bora Bora. Okay, so the island of Bora Bora. You see the volcano in the middle and the atoll ring around the outside. Like I said, so I'll show you some more. I'll show you some more pictures in class of some really, really cool atolls. Then the last thing to finish up this section are just some hotspot volcano examples. So you should hopefully already remember the Hawaiian examples. Kilauea is a great example. If you can't remember how to spell Kilauea, it's Kileua. So Kilauea, that's the active volcano on the Big Island of Hawaii. Mauna Loa is that huge one that we talked about, mainly most of the Big Island of Hawaii. So that's a good hotspot example. And you see there are other ones that you could write down. But I'd like you to write down another one that's in the United States. And it shows you that not all hotspots are underwater. There are some that are on land. And this is Yellowstone. So Yellowstone is an example of a hotspot volcano. In the past, it's erupted. You know now it has all the geysers and hot springs and everything like that. So you know there's a big thing of magma underneath it. Well, in the past, it's actually erupted. You see, when it erupted about 6.5 million years ago, it covered kind of the whole Northwest in basaltic lava. Imagine if it did that today. If it erupted now and covered all this in lava, all those cities, everything would be wiped out as it covered in lava. Lots of times people call Yellowstone a supervolcano. It is a huge volcano. When it goes off big. It can go off big basaltic like this because it's getting that magma from deep within the asthenosphere. Or if it's worked in enough of the silicates, it can actually be very explosive too. And you could have this huge ash covering kind of most of the United States. So Yellowstone is a place where seismologists are watching very carefully because they want to know what's happening with it. Is it going to erupt? Is it not going to erupt? And again, you can see this idea that the hotspot doesn't move. It's the plate that moves. So the hotspot of Yellowstone is right here, but the plate is moving. You can see plate is motion here this way. Okay, so 12.5 million years ago, this place in Idaho was on top there. Okay, this many years ago, whatever that was there, 10.3 million years ago, this was there, 6.3 million. So you can track and see how fast it's moving. So Yellowstone is another good example you can put down for a hotspot volcano example. That's it for our quiet eruptions. Last volcano type we're going to talk about then are the violent eruptions, and we'll have a couple examples of those to do.